Okay, so up to now we have discussed about what are the various types of demands. Okay, so in these types of demands we have seen domestic, industrial, institutional, and everything. So now, what is this water demand actually? Once again, we'll revise. So it is the amount of water that is demanded by a particular community. Okay, if you take your example, how much water you require in a day, that is your demand. Okay, that much amount of water you require. Then, if you take the example of your own house, then what is the demand of your house? That is how much amount of water is required, or what is the demand of your house in a day. If you expand it to a higher scale, then it will be what will be the demand of your community, that is nearby locality. Or if you are living in an apartment, then it will be what is the demand of the entire apartment system. So to design a water treatment plant for a particular community or a particular city, first we should understand what is the water demand. That is how much water is expected or is required by that particular community. For that demand, we will design our water treatment plant. Okay, sounds good. Now, what is this variation in water demand? So I hope now you have understood what is water demand. Now the meaning of variation in water demand means, if we take the example of summer, okay, so let's take summer and winter. So among these 2 months, what do you think, in which month the consumption of water will be more? When I say consumption, okay, so this consumption is nothing but the demand only. Okay, demand for water or consumption of water, same thing. Now, so in which month do you think the water demand will be more? Obviously it will be in summer, okay, than in winter. So this is what we call it as seasonal variation. Okay, that is season to season or month to month, there is variation in the demand of water. If we look at daily point of view, that is if we take Monday, Tuesday, Wednesday, Friday, Saturday, and Sunday. Now if we take an example of a particular family in which all the members are working, okay, so basically the working days are Monday to Friday. Saturday, Sunday, we'll assume that there is holiday. So in this Monday to Friday, most of the time these people will not be present at home. Okay, they will be present at their offices or their work site or their industries. So the demand for these days will be less. Amount of water which will be consumed at their home, it will be less as compared to the Saturday and Sunday. Okay, if we are assuming that they are not going Saturday, Sunday anywhere, then if they are present at the home, then obviously as they will be present throughout the day, there will be more consumption. Hence the demand for water will be more in the weekends, that is Saturday and Sunday. So this we call it as daily variation. This we call it as daily variation. If we take some values to this, let's take some values. Like Monday we have 20, then this is 19, 21, 20, 19. So on an average you can see that it is around 19 to 20, that is average value for this 5 days. And on Saturday and Sunday it is 35 and 35. Saturday 35 and Sunday 35. So for this all the values, we can find out what is the average daily demand. I hope you are getting now what I am trying to say. Average daily demand. How to calculate average daily demand? You just add these all demands, okay, up to 35. And how many values are there? 1, 2, 3, 4, 5, 6, and 7 for the 7 days. So if you calculate this value, I'm assuming here some value, okay, this I am not calculated. So let's take it is coming as 25. So the average demand is now 25. That is average daily demand is 25. Now, so coming back to the main point here, So this is the overall concept of variation in demand. So we have seen the seasonal variation, we have seen the daily variation. Now in a day, let's take an example of 24 hours and plot it here. So this is the demand of water, okay, and this is hours. So in hours we will take it from morning up 2 to 4, then 6, 8, after 12 again 2 p.m., or we'll take this as 14, okay. So 14, 16, 18 and so on. Now, so 2 to 4, what will be the demand? So this demand, if you see, I am drawing here a curve here. So 2 to 4, this is in the morning, okay, 2 to 4 a.m. Most of the people will be sleeping only, so the demand will be very less, okay. So let's take up to 6, there is very less demand, and from 6, when most of the people will start waking up, all their daily activities will start and the demand will keep on increasing, that is the demand of water will increase. So let's see, let's take it up to 11, that is morning 11 a.m. The demand has increased, and after 11 a.m. what happens generally? Most of the people leave for their jobs or their work. So then the residential demand once again it decreases up to evening part, and after evening once again this will try to increase. So this is an approximate diagram that we have drawn which shows the variation in demand, okay. So no need to remember this, just conceptual point of view try to understand. So this is the variation in demand of water for a particular community, okay. So now this each point represents one value here, that is what was the demand of water at 6 a.m., then what was the demand at 8 a.m. So these all represent some values here. So now if we take an average value of this, or if we calculate the average of this, then this is the average line. See, we have calculated here average daily demand. So here we can calculate average hourly demand. So this line here represents average hourly demand. Okay. Now, if we know this average demand, then we can design it for the maximum value. What will be the maximum value? So this particular thing here, this is the maximum value. So if we know this average value, we can find it out the maximum value by using certain formulas, and these formulas are given by a scientist whose name was Goodrich, okay. So Goodrich formulas are there which are used to find out the maximum daily demand and maximum hourly demand. So let's write down those formulas now. This formula is very important. So the first formula is about maximum daily demand. Maximum daily demand. So maximum daily demand is 1.8 times of average daily demand. Okay, this average daily demand I am representing it with small q. So this is 1.8 times of small q. Second one, maximum daily is done. Now maximum hourly we will take. So maximum hourly demand, this is equal to 1.5 times of average hourly demand of maximum demand day. Okay, this formula we can upgrade it. This is the main formula, okay. So this can be updated like this. So average value, that is average hourly demand for the maximum demand day. So we have calculated how to calculate the maximum demand day. So maximum demand is equal to 1.8 times of average demand. So we can write it 1.8 times of average demand, but we have to take the hourly value. This will give us the daily value, okay. This demand, maximum daily demand we are taking here. So to convert it into hourly, we have to divide this by 24. Okay, so this is the formula. Now if you multiply 1.5 into 1.8, it will give 2.7. 2.7 multiplied by q divided by 24. This is the formula for maximum hourly demand. Okay, where q stands for average daily demand. Now write down the next one, maximum weekly demand. Maximum weekly demand. So this is equal to 1.48 times of average weekly demand. Then last one is maximum monthly demand. Maximum monthly demand. This is equal to 1.28 times of average monthly demand. Okay, so now these are all the values here. Very important. You try to go through all the values. These ratios are also important, 1.5, 2.7, 1.48 and 1.28. So I'm giving you one extra formula here, so you can write it down. That is the main Goodreads formula, from where this all the values are derived. So the Goodreads formula is P is equal to 180 into t to the power minus 0.1. So this is never asked up to now, but if it is asked, then you should be able to correct mark the option. Okay, directly the formula can be given, like which of the following is the formula for, or it is the Goodreads formula. So where P stands for percentage, P stands for percentage annual average consumption, annual average consumption for t days, and t is time in days. T is time in days. Now we'll take one example here. So we have seen for maximum daily demand, what is the formula? It is 1.8 times of average daily demand. So daily demand, to calculate daily demand, daily means we have to take one day, that is t will be equal to 1 day. Substitute p is equal to 1 here, so p is equal to 180 into 1 to the power minus 0.1. So this will be 180 percentage. 180 percentage means 180 divided by 100, that is 1.8. So this is the factor that we are multiplying it to get the maximum daily demand. So similarly you can also find it out, for monthly. So for monthly demand, t will be equal to, in a month let's take 30 days, so t is equal to 30. So p is equal to 180 into 30 to the power minus 0.1. So this will be coming around 128 percentage, that is 1.28. Okay, that is 1.28 maximum monthly demand. So this is how you have to calculate the variation in demand. These formulas are very important. This concept I have explained it to you about the variation. There are seasonal variation, daily variation and hourly variation also. So to take into account and to design the systems properly, we have to take the maximum daily, maximum hourly, and similarly weekly and monthly. So now in the next video we will see what is the meaning of coincident draft.